So now we're going to move to the next step, which is dimension reduction. So I'm able to tokenize all my words. I see all my words. I can understand how they're used in the sentence. But do I need all these words? Are they really necessary to understand the subject matter in each sentence? Well, no. So the first thing we're going to do is we're going to remove what are called stop words. So another vocab word are stop words. These are words that don't carry any information. So the, and, those types of words, you can just throw those out right away. You really don't need those to understand the context of a sentence. Then we're going to remove our punctuation. You could argue maybe question marks should be something that you figure out how to enumerate that. But generally, you just throw it all out. We don't need punctuation. We don't really need to know where sentences start and end. That's just the general approach to doing this. You can get more complicated. You could take that type of stuff into account. So if we want to remove words, and this is literally just a list of the popular English stop words, you could add words to it. So oftentimes at GSK, a stop word for us would be GSK. We don't care if someone said GSK. That's going to show up a lot. Therefore, we're removing something that really doesn't help us. We already are pulling things about GSK. And then we have a remove punctuation, and you can see what we're left with. A little hard to understand the first sentence now because that was sort of a question, but also a statement at the same time. So maybe if you read this, you would think that they did run the ball when they actually didn't. So again, maybe something to take into account, but this one, I still understand the sentence just fine. We have still all the important information. Then we're going to do something that's called stemming. This is another vocab word. So the idea of this is we're going to take different variations of the same word. So you have past tenses, you have plurals, things like that. We really don't need all of that. There's really not that much information stored there. And so a stemmer will remove plurals, get rid of past tense and just make everything present tense. And then really, really aggressive ones will actually literally take words and bring them back to their most base element. So here's an example. This is simple sort of normalizing verb tenses. Walking, walks, and walked. We can literally map all those just to walk. That's really all you need to know. Now here's a really aggressive stemmer that can take apply, applications, and reapplied and understand that that is really what the base word there is, apply. Stemming works well sometimes, doesn't work so well other times. Generally how it's done is lookup tables are popular. Again, text analytics is not always that fancy. Sometimes it's literally just I made a really, really big table and we're just going to parse through that. Other ones will just literally just remove all suffixes. So you see ed at the end, get rid of it. It ends in s, get rid of it. Ends in ie, reduce it to e, just to I. Lemmatization is where you're actually going to use the part of speech to inform your stemmer. You can find a good example of one of these. Again, this will probably be something a little more custom built. So if a word is used as a noun versus a verb or as an adjective, the stemming will change. Oftentimes it's just a basic Boolean logic. And then really fancy ones will incorporate some type of probability models using previous data. Again, oftentimes it's very similar as a Bayesian spell checker where you have some prior and then your observed usage of the word. The two most popular stemming algorithms are the Lovins and the Porter stemmer. They're both fairly old. Hence why stemming hasn't really taken on it's used a lot, but how well it works is questionable. And these are both just rule-based suffix stripping. So again, sees ed, get rid of it. And you'll see how this can make a little challenge. Porter's a little more advanced. It has a 6-step process to doing this, whereas Lovins only has 3. These are really not as fancy as you think. Like Lovins actually enumerates 350 different types of suffixes. And then literally just kind of throws them all away and then does a little bit of adjusting. So the the sentences I have are not great for stemming, so we're just going to sort of make up our own. So we have the walks example, then I added this fishing one. So the default stemmer in TM-map, so you use stem document, the algorithm can change depending on the language, is the Porter stemmer. And you can see it gets rid of all these suffixes. So walk, walk, walk. It's not aggressive enough to understand applications, so it kind of just, you can see it can get the ed out of there. And you can see even this ends in a y. It's going to make that an I, so it maps together with these two. It's another thing, you lose a lot of interpretability of the word. And It actually did pretty good with fish. It got rid of the I and D, ED. Didn't get rid of the ER, because I obviously would be talking about Sir Ronald. So we want to leave that as full. Now, if you want to use the love-in stemmer, you cannot, they don't have that in TM. So we're going to use something called the rweka package. rweka does not interact well with some of the dependencies of TM. So best way to do it, install it, do not load it. So don't call library or require, and you're just going to give the name of the package and then these 2 colons and call the functions directly. So this is how you call the love-in stemmer. And it's very basic and kind of just fails miserably at all of this. Isher is probably one of its suffixes, and it didn't have a good rule for that, and so it just threw it all away. And stemming, they've actually, one of the popular undergrad projects is to do an analysis of how well does the end result happen if you do stemming versus not stemming. So imagine sort of doing a simulation. Oftentimes there's literally no benefit to stemming. So maybe if you have a ton of documents, you'll get some benefit, but we're going to talk about a much better way to reduce your data. And that's by using synonyms and building a thesaurus. This works really, really well. So not only would you be mapping words that are similar in the base word, but you would also then map words that all have the same meaning. Okay, synonyms again. So imagine how much you can reduce your data if you can get rid of you can reduce all words to some preferred term that they're all the same. Hard thing is this can be very involved. There's not a lot of good thesauri out there for free. Actually, in fact, IBM has their text analytics, SAS has theirs. They don't do that much fancy stuff usually in terms of the algorithms they use, but they invest a lot of time into building really good thesauri, and then they make them subject specific, which is really where you get really good results. And then they obviously package those up and charge an extra to an add-on to get the special social media one. You know, this is an extra $100,000. You may have to build your own. So where do you start with this? Again, very involved, but you can really get a good payoff at the end. So Wordnet is it's a compilation of the entire English language put together by the Princeton University Linguistics Department. Nice thing is it's free. And to say that it's just a database is underselling it a little bit. It's really a ontology that understands and maps all the different relations of words in the English language. What words are similar to each other, what words are not. We go from homonyms to synonyms, all these different things. It's actually a pretty impressive project that they started in the 80s, and it's all free. So if you want to apply synonyms in R, they used to have this replace words function, but they threw it out. I don't know why in the new version, but you can still go find it online. It's very easy, or you can just steal mine. So one thing would be, let's say I have sports data, and I don't need to know what specific team they're talking about. I just need to know it was like a football team. So you could create your thesaurus of all the different NFL teams and simply map them to it's a football team. And here you see replace words. It's really just using a G sub, goes through and reduces all those. So now I don't have all the NFL teams. One thing that I saw right away was ran and run. For some reason, the stemmers don't take care of it. It should, because it's not really stemming, I guess. It doesn't. So these I don't need to be two different words. I'll just replace them. You can then call Wordnet if you want. They have a package which is literally just an interface to the entire dictionary that they've built. You have to download the dictionary. It's not that big. And then you use this, which will allow you to interact with it within R. They have a similar package in Python. So you're going to use this what's called synonyms function, which is in Wordnet. So this is one of their examples. I put the word company, and what's the part of speech for it? Well, it's a noun, and it gives me all the possible synonyms. It's very, very robust. And you'll see that in examples. You see, we go all the way from fellowship and troop. And so I tried data. It actually gets information as well. But just to give you an idea, if let's say you put in run, which is a pretty common word, it gets all these like head for the hills, hightail it, all the way to execute as if you were running code, campaign if you're like running for office. It's very robust. In fact, it's both an advantage and a disadvantage. I would not apply Wordnet directly because really campaign is very different than the other. So there's a lot of different ways to do this. But this is a really good jumping off point. Again, building your own thesaurus is how you get the best results.